Welcome to Cyber Sentries from Paladin Cloud on True Story FM. I'm your host, John Richards. Here, we explore the transformative potential of AI for cloud security. Our sponsor, Paladin Cloud, is an AI-powered prioritization engine for cloud security. Check them out at paladincloud.io. On this episode, I'm joined by Zack Butcher, founding and principal engineer at Tetrate. Tetrate provides a consistent way to connect and protect thousands of individual microservices. Zack and I will discuss how to know if your environment is zero trust and the 5 critical pieces necessary to achieve zero trust. We'll then look at how those principles apply to AI services to ensure they and your data remain secure. Let's dive in. Hello, everyone. Welcome to today's episode of Cyber Sentries. I am absolutely thrilled to welcome a real pioneer in the world of microservices and security. Our guest is Zack Butcher, founding and principal engineer at Tetrate. Zack, thank you so much for joining us today. Welcome.
Thanks for having me. I'm excited to be here. I'm looking forward to it.
Before we dive into more around the security, I'd love to hear how you kind of got into this role, founding member, like what led up to being such a core piece there early on, and kind of what was your journey to that spot?
I started out working in Google Cloud. Actually, I owned projects. So if you ever go to Google Cloud, you make a project. That was my baby for a long time.
Oh, nice.
And kind of through weird historic artifact, that team was part of the team that was responsible for the API gateway inside of Google. So I was working on unrelated, kind of not on API gateway stuff, but there's a decent little bit of crossover between those parts of the organization. I had spent about 2 years on the team, and we shipped basically this service mesh architecture inside of Google to 100% of the workloads there. It's another part of the team, and I got to kind of witness the second hand. Right. I helped out a little bit with some parts of it, but I was mainly on GCP stuff. But I saw this ship, and I shipped actually a service on top of it a little bit later, and it saw kind of some of the power firsthand. Then some of the folks that I worked with in that larger org said, hey, we're going to go off and start this open source project internally at Google on this service mesh thing. And we didn't call it service mesh at the time. And it would be probably another 8 or 10 months before we named that project Istio. Eventually, but I joined that as one of the original engineers on that project. And, it was an exciting for me. I was like, hey, inside Google, it's a very much a walled ecosystem. And so being able to go and work on open source things was something that was really appealing to me. And I thought this was a really interesting problem set. I actually originally worked on policy side. So Istio used to have a whole policy engine and some stuff that's been stripped out. I think it'll come back. I've given some talks about how I think it'll come back later. We saw that Istio solved a set of problems for users on the ground, but couldn't get some of our leadership to orient around some of those problems that we were seeing on the ground talking with users. And of course, that's frustrating, right? When big companies move slow. And so myself, the original product manager for Istio, Varun, who's currently CEO at Tetrate now, as well as some other folks got together to start Tetrate to exactly try and solve some of the problems we saw users trying to solve with the service mesh, which wasn't kind of as tactical as like, let me deploy it, but we saw repeatedly this problem of, I want to move to microservices. I want to get into cloud. I have some stuff on-prem. I maybe have a footprint over there, but really, how do I start to connect these things securely? How do I understand what those connections are doing? And then how do I apply policy to it? And that's a really compelling set of features, wherever you're running your infrastructure. And I think it actually makes it easier to run your infrastructure across different sites. So that's really what we started to solve. That's how I kind of got started there at the company. It's been 6.5 years now. We've been making it happen. It's been really good.
That's really like one of the best startup stories, which is the stories where there's a problem. So we got together, a bunch of folks, and said, how can we solve this? Let's just create a small group, move really fast, and try to fix this challenge that we see in the market. And so I love that story. I'm glad it's been so successful how has it been being on that journey now, 6 years down the road, and going from scrappy where you were at to now, a big player in the space?
Yeah, it's been really surreal, actually, in a lot of respects. It's also been a lot of hard work. I kind of joke with I joke with some of my coworkers. Sometimes it feels like it's been like 3 months, and sometimes it feels like it's been 15 years. And you turn around and it feels and a lot of times those are back to back days. So it's been a lot of fun. It's been a lot of hard work, but I mean, I think I think it's a good startup story because fundamentally, I think any successful startup you have to be driven by what a customer needs, right? If you're not trying to solve a customer problem, then you're doing some science.
Yes. Well, okay. So you got involved in Tetrate, but you've also, like specifically in this world of security. I know you've been involved with NIST. So how did you end up going so deep on the security aspect, and what's that look like?
Yeah, so I mentioned, I worked originally on the policy side of Istio and all of the security and all. I say policy, and people maybe actually hear security. When I say policy, I actually mean like any decision you want to make at runtime at all ever. But as we were starting Tetrate, our other co-founder, JJ, who's CTO, had been doing research in access control for a while. He was at Twitter and was grappling with some of the problems around Twitter trying to move into cloud. And one of the first problems you run into, practically speaking, is how do I map identities between these different environments, like service identities and runtime identities and things like that. And so he had gone off and had done some research around access control and different things, and started to reach out to some of the NIST folks around some work that they were doing. And it just so happened that literally the first week that Tetrate existed, we were meeting up in our office at the time in San Francisco, and David Ferriolo, who was the main guy at NIST, happened to be in the Bay. He happened to be there, I found out later, because he was receiving the IEEE Lifetime Achievement Award for creating RBAC.
Wow, incredible!
Yeah, we should do a whole episode about him. And we can have him on. He's amazing. He's been doing access control since the 70s, and really basically every large delta in access control that you may know about. ABAC was a phrase he coined. RBAC, he wrote the book, literally. Great guy. We reached out to him to ask about some of the access control because the service mesh with its sidecar next to every application is really well suited to implement policy. And so that was some really interesting access control stuff that he was doing. And we started to develop a relationship together, and we got a collaborative research agreement with NIST as Tetrate from the very early days. Out of that relationship, we came and I actually came to some of the NIST folks originally and said, hey, look, we think that there needs to be some guidance around some of this microservices, some of the move to cloud, some of the service mesh stuff. And so let's write some SPs. That's what NIST does. And so we started to do that together. And there's a few series of SPs now that I've helped co-author. There's the SP 800-204 series, and there's quite a few entries in that series today. And that's really all about microservice security. And it covers stuff from just high-level overview of what are some of the threats you need to worry about, down to like lower-level security, into, I've been able to pull in excellent co-authors and probably some folks even you've had on the podcast to help co-author some things around stuff like supply chain security and some more. That's a great set of papers. The second set that we work on together is 800-207 series. That's the Zero Trust series. And that one's an important one. That's front and center in a lot of people's minds because of things like the executive order was 3 years ago mandating Zero Trust. Funny trivia fact, during college, I actually worked for a Colonial Pipeline Company in their IT department, which was the organization that was compromised, that resulted in the Zero Trust executive order. And subsequently, I've actually then written some of the Zero Trust guidance so it's kind of a funny full circle piece. But that Zero Trust piece is a key one. And with 207A, we really wanted to give a practical runtime definition of Zero Trust, because quite frankly, I was tired of a lot of vendor FUD around what is Zero Trust and what is not.
Yeah, I've talked to a lot of people who are like, well, and because of these confused definitions, who some people are like, well, it can't even exist because they've come up with a definition that then can't exist. So what can you share some of the progress in that space to get around a more shared definition, and hopefully at a level that, maybe if people who aren't deep into engineering, they can still understand and get an idea of what is meant when people are saying zero trust, and here's why it's so important.
Yeah, exactly. So there's kind of two pieces that I want to split out. So when we talk about zero trust, fundamentally, it's a posture and it's a way of thinking in the organization. And it's not trust nothing, but it's make your trust explicit. I actually pushed kind of hard for us to change the name to zero implicit trust, because I think that's actually much more representative of the mindset that somebody needs to be in compared to zero trust, right? It kind of gives the wrong, but it's not as catchy. It's not as marketable. So what do you think? What are you going to do?
Right. But I do love that as a way to help. I suddenly have a very different understanding, even with just that short definition change.
Good. That's awesome. And so, that's a huge mindset shift because it really encompasses people, process, and technology. 207A that I authored is much more focused, and I wanted to give a runtime definition of what zero trust means from a policy perspective, right? So you can talk about all the process and everything that needs to go on top of that, but like at runtime, people want to know, like, am I secure or not? Am I in the right posture or not, right? And so I'll give the definition that we give in the SP. I think it's easy enough. I joke it's 5 points. I joke, we can count to it on one hand. But I'll also maybe give you an intuition that motivates it. So I'll start with the intuition, which is this. You are in a zero trust security posture if I can pick any workload in your infrastructure and expose it to the internet, and the impact of that is minimized or mitigated. Right. That's really because, how would it be exposed to the internet? I don't know. Developers make mistakes every single day. People misconfigure viral, any number of malicious or non-malicious ways.
Yeah, I feel a little attacked, but it's also completely true. So I can't say anything.
I make as many mistakes. I joke when we talk about the service mesh helps with reliability. The way I get up there and I say, who's caused the DOS internally? I have. That's who's caused the security? It's, so we want that mindset of, if my application is exposed to the internet, it shouldn't be, but if it is, what's the risk? What's the impact? And can I mitigate that, or how have I mitigated that? And when you can say with a straight face that, hey, my system is as secure if it's internet facing or not, we can argue, I give an extreme definition, but that's where you want to go to directionally, then you're in the right mindset.
Yeah, that's a really nice goalpost to say, oh, here's this spot I want to be at.
Exactly. And so then how would we ever get there? Right, is then the next question. And we focus at kind of a higher level layer. So we're assuming you're doing good bookkeeping under the hood. You're keeping things patched, you're keeping things updated. So now what are the security things? And we argue there's 5 policy checks you need. So 1, all of your applications should be doing encryption in transit. Right. So even out the gate, for example, if you have an internal PKI and it's exposed to the internet, you're not even going to be able to connect because there's no trust. That's one of the ways we can talk about implicit and explicit trust. PKI talks about trust explicitly. That's the first one. Then services need to be authenticated and authorized. So what do I mean when a service is authenticated? We need a service identity that identifies the application, the thing that's acting. And we want explicit policy. We want to be able to say, hey, there's a front end and there's a back end and there's a database. And the front end can call the back end and the back end can call the database, but the front ends cannot call the database. Simple. That's service identity. I gave you 3 identities and I gave you an authorization policy. There are 3 of them, right? And then we want end user authentication and end user identity, right? So it's not enough to say the front end can call the back end and the back end can call the database. We want to say the front end can call the back end if there's a valid end user credential containing the correct scope, right? And the backend can call the database in the presence of a valid, and when I say valid, I mean authenticated and end user credential with the correct scope. What I'm meaning there is authorized to access the resource that's under question, right? And so I'd argue if you have those 5 controls, and not just me, but we argue in SP 207A, if you have those 5 controls around all of your applications, then you are in a zero trust posture, or at least, you're in the right mindset. There's more you need to do besides. There's the people on the process side and all of that. But from a runtime definition, if you can go, I'm doing those 5 things, you're on the right track. And that's exactly what we argue. We go on to argue a little bit more. We talk about how you can relax some of the network policy that exists today that historically I see is a really big pain point that hampers agility and the ability to move quickly. And so we argue around how you can start to relax some of those network controls if you augment them with those 5 controls that we talked about on top. That what we call identity-based segmentation is the snazzy name for those 5 controls.
I love it. Thank you for the easy to understand descriptions. Even I was able to understand those. So thank you. So I am curious, how hard was it to get consensus around this idea of a relaxing controls? Because I feel like in security, you never want to be the person who said, we can relax this now, because sometimes there's a bit of a paranoia that seeps in. I love the fact that that it's almost saying, here is a better method, so much so that instead of these almost like walls that you tried to set up on your network, we're going to have kind of this intrinsic authentication to really drive this instead.
So there's maybe a couple pieces to pick apart. So one, why did we do the network segmentation and all to begin with? And that's because the only notion of service identity we had was the network identity. So that was the only tool we had for service-to-service authorization. So an important thing I say, let me actually back up meta. In these NIST SPs, the goal is never to introduce new ideas. So those 5 things I've talked about, anybody who's worked in security would tell you, of course, you need to authenticate and authorize. And of course, you need encryption. And of course, so the goal is never to introduce net new ideas, but the goal is to say, hey, we should be applying these things that we know about and are good in a best practice way.
So it's like identifying people who are doing or groups doing best practices and really defining standards saying, hey, we see that this is the future, the proper way.
Exactly.
Let's expand this out even further.
Exactly. And that's part of the reason, that it's valuable for NIST that somebody like me kind of helps, because in my, hat that I wear here at Tetrate, I get to kind of survey a large number of organizations and how they're doing some of these things, how they want to do some of these things. And I can also flavor that with some of the work in GCP. I mentioned I own projects. I didn't mention that I also worked extensively on the identity and access management system there, the hierarchy and all of that. And so for me, this has always been kind of an interesting area as well. And Google does a bunch of zero trust things that I got to see internally. And so it's been, a synthesis of all of this stuff that we're seeing and best practices that we know about to bring together. And then, the other thing I'll say is security is always a trade-off, right? I joke when I give some talks live, what's the most secure system? It's a computer that's turned off and locked in a safe. The problem is it's entirely unavailable. And so fundamentally, security is always a trade-off between availability and assurance, right? And so security always has to be thought of as a spectrum. You are always making trade-offs. It's never binary. And so really what we're saying is that if you are increasing the assurance at higher layers in the stack, and assurance is a key word that we've lost in the security language, I feel like a lot of times. In risk-oriented organizations, I hear about assurance, but if you go back to some of the literature in the 70s, 80s, 90s, assurance is a big thing that we talk about a lot. What is your assurance that things are safe or not safe, right?
So we're picking up on the idea of, you mentioned assurance, but being able to relax some of these network controls versus...
Exactly. So we get assurance at a higher level, right? Because we've added, that identity-based segmentation, those 5 controls. And so the argument is that we make in the paper that where other lower level controls, like, for example, network segmentation, then hamper agility of the organization, we should feel justified in trading off because we've increased assurance elsewhere. And that's fundamentally what we lay out. And we talk about even some runtime patterns. Good parallel we give in the paper is the idea of a VPN. What does a VPN do? We deploy some gateways around, and it allows us to connect to network domains. It allows us to transfer network identity across a boundary. And we use that policy to determine who can access what. Are you on the VPN? Well, then you can access the resource, right? We propose, and actually Tetrate helps implement a bunch of folks, a very similar idea, but at layer 7 with application identity, going over a set of Envoy gateways, because Envoy is the data plane technology that we use that lets us link together different sites at an identity level. So where a VPN lets you link together different networks at a network level, here we're linking these different identity domains and facilitating network connectivity so applications can go across. And that is another example place where you can use a policy like that, where these gateways communicate and there's simple firewall between the gateways, and eliminate the kind of crazy firewall rules that are required for in-by-in apps to communicate across the boundary. That's the same kind of reason we use VPNs to access internal systems, right? Because it simplifies that access model. So again, something not fundamentally new, but applying these techniques at maybe at a higher level.
Oh, and then I guess the metric, it sounds like you're saying here is, you're like, if you implement this, you end up with a higher level of assurance.
Exactly.
And so then you're okay saying, hey, I lessen this because my end result is I'm more confident in the connection and security we've got here.
Exactly. That's exactly correct. And, we're not saying, hey, get rid of all your network level security. But we are saying where it is painful and where it causes organizational pain, when, because of process, because of slowdown, because of that, then you can justify relaxing it in exchange for these other controls. And then maybe what is implicit here that we're saying as well is that identity level controls are easier to manage because they're closer to what human beings can read and understand compared to network policy like CIDRs. What's a CIDR? Which things are on the network tag? Who knows? But I can read front ends, and I can read back end, and I can read the front end is allowed to call get on the back end. And that makes sense to me as a human. And therefore policy we can be more confident in, we can author faster, right?
I love that. I love any time we can make things easier for actual humans to understand. It lowers the chance of mistakes, and
Exactly.
People are able to onboard, learn faster, and kind of adopt that. That's awesome.
That's exactly right. And so that really gets to the heart of what we mean with this, relax the lower level, augment with these higher level controls, and get agility out of it because you're able to move more quickly.
How much do you see, because you also had that work in kind of the mesh microservices space, how much do you see the growth and adoption of that driving some of these new changes? Because it seems like there's some connection here between these two.
For sure. They go, I see them go hand in hand, right? So, part of it's because I work in one foot and help write them in the other. And so, of course, I'm going to write about what I've seen. But I do think that we're genuinely capturing kind of some of these larger trends. The other thing I'll say is, and we've written about in the SP204 series, that we actually do believe that the service mesh is the best way to implement a lot of these. And this goes back to some of the 1970s arguments around the security kernel and the reference monitor. If people want to go Google those things, security kernel is exactly where we get the idea of the operating system kernel. So the idea is that you want a common layer that is high assurance. This is where some of the assurance language comes from, the idea of the security kernel, that does all these common security functions on behalf of all the other stuff that's running. That's exactly what your operating system kernel does on behalf of user space applications. So the NIST was very interested in the service mesh as in the idea of it being a common enforcement layer across all the heterogeneous applications in your distributed system. And so, when we said, hey, here's the paradigm that we do things, and we were working on access control policy, for them, they stepped back and they said, if I draw the architecture of the idealized access control system, it actually looks the same as the architecture of the service mesh. Isn't that wild? We say, and it's not a mistake that it looks that way. The two developed in divergent ways, but they have a common set of needs that brings you to that common architecture. And so that's why the NIST folks thought, hey, the mesh is really compelling and really interesting. It lets us get back to some of these, at this point, half a century old ideas around how we want to secure systems that we've been using for half a century to secure our systems. So there's some there, the ideas.
Yes.
That's why it was compelling, and that's why we had that crossover, I think, between the mesh and some of this more fundamental security stuff.
Well, I love that like the finding is that security itself, the core concepts aren't what's changing. It's easy as a new technology comes along to say, we need a whole new way of doing security to handle this, when often it's more, how do we look at what we're already doing and figure out how to move that into this space? Yeah, adapt it over. So I love that. Hey, we know this is a secure way to function. How do we make that happen here at a, obviously much larger scale, but kind of still using those same concepts?
Exactly. And that's the way I think that's when you're onto something like fundamentally powerful, when you find this concept like that can scale up. Right. And that for me is one of the things that's really exciting about a lot of this work.
Yeah, for sure. No, as we teasing there a bit, all the new technology. Obviously, AI is, everybody's like, hey, how is this going to impact things? How do you all see? Are you seeing anything where this fits in to either help with the security here, or is it something like, oh, this is still a wild card, we need to figure out what we would do? What are your thoughts about how AI can be used for security, kind of on this level of authentication and identity driven?
Yeah, so I see maybe two aspects around AI. So first, I'll talk about how can it be used in some of this stuff. When I said, hey, you need to authenticate and authorize services and authenticate and authorize users, that's a very short thing to say that belies a lot of complexity and a lot of really hard and challenging engineering. One of the really interesting things is systems that do risk-based access, right? So, for example, hey, I happen to live in the U.S. and I access from an iPhone, and suppose I've been accessing a corporate system in the U.S. from my iPhone for the past couple of hours, but I go offline and suddenly I pop up in say Eastern Europe on an Android accessing the same system. Should I have the same access or not? Well, it's riskier. Why is it riskier? Because you know my context. How do we make that decision? That is an interesting place where I think we can use AI in some of this policy and decision making. And it still needs to be auditable, obviously, and there's a lot of stuff that goes into that, because people get really angry when you don't allow their access in the right way. But that's one of the compelling places where I think that there's some interesting policy decision making that goes in, right? The other big place where AI systems come into play here is that they need to be secured just like any other system that we're dealing with, right? And so those 5 fundamental principles around building a zero trust system need to be applied to the systems that we're training, to the systems that we're serving AI with, and similar. And then maybe the final piece that I think is really interesting, and I think this maybe has been, there's been some news stories around prompt injection and things like that. But what is the data provenance, and what is the data that's coming out of your AI systems as well? And that's one where additionally, I think because the service mesh as the technology is in the data plane and can see the bits and the bytes that are going to and from the user, you're in a unique position to be able to report metrics and potentially even enact policy and do things like stop data that's going out. I think that'll be another interesting area in the future. So this data level security in implementing that. And I think that's important regardless of AI or not. But given how AI systems are being deployed and used today, I think it's maybe especially relevant.
Yeah, because you don't quite know what's now. When you talk about this, is this plain happening in the layer where the AI is accessing the data, or as the AI is transferring that data out to whatever the end recipient is?
In the fullness of time, we will see controls happen in both places. So for me, with the service mesh, it's really where you respond to user traffic, right? Because it's really more in the network linkage between different parts of the system. However, that data governance, data provenance, data labeling, and then how that is allowed to go out to the system, which is kind of internal to the model in some sense, is essential. And I think we can use a lot of similar techniques. A lot of the same kind of access control, for example, that we use for service to service is readily amenable to being used for doing data level access control as well. And that may be a quick teaser. I know we're running up on time. So a quick teaser I'll whisper for people is the name of some of the access control research that we do with NIST is called Next Generation Access Control. And there's a data flavor of that called NDAC, Next Generation Data Access Control. And those are really cool things. There's some white papers. There's an ANSI standard around it. That's how we do a lot of the magic with service-to-service access in really sophisticated ways. It's an awesome graph-based access control system, and it's part of what I research with NIST.
Ah, incredible. Well, that's a perfect teaser here to end us on. Zack, before I let you go, thanks again. But can you, how can folks get a hold of you? Anything you want to shout out that folks should check out? And we can drop some links here to anything you mentioned in the podcast notes.
Yeah. Thanks for listening. Certainly, we'll drop some links for some of the NIST SPs for folks that have to work in the security space. I really try and write readable SPs. A lot of the stuff that comes out of NIST I know is painful to read. Trust me, I know intimately because I've had to read them. I try to make them at least a little bit more readable than average. That's a low bar, but we try to do it. So please check those out. If you're doing meshy stuff, if you're looking at service mesh, if you're looking at how do I connect and secure my workloads, definitely come, drop by Tetrate. We can help you out. If you're interested in learning, there's a bunch of stuff at academy.tetrate.io that's free training on Envoy and Istio. A bunch of stuff that's valuable there. So check it out. And John, thanks for having me today. It's been a blast.
This podcast is made possible by Paladin Cloud, an AI-powered prioritization engine for cloud security. DevOps and security teams often struggle under the massive amount of notifications they receive. Reduce alert fatigue with Paladin Cloud. Using generative AI, the model risk scores and correlates findings across your existing tools, empowering teams to identify, prioritize, and remediate the most important security risks. If you'd like to know more, visit paladincloud.io. Thank you for tuning in to Cyber Sentries. I'm your host, John Richards. This has been a production of True Story FM. Audio engineering by Andy Nelson, music by Amit Sagi. You can find all the links in the show note. We appreciate you downloading and listening to this show. Take a moment and leave a like and review. It helps us to get the word out. We'll be back October 9th, right here on Cyber Sentries.